Hello everyone and welcome to this Genesys Customer Care Tech Tutorial. Today we have Andy Votor from the Voice Self-Service team presenting Genesys Interaction Recording installation, and this is part one of a two-part tech tutorial. Also we have Olga Luhova from the Voice Self-Service team with us to answer any chat questions during the session. Just to address a few logistics before we start the presentation. This session will be recorded and posted to the Tech Tutorials page of the Customer Care website in a week. You will receive an email with the recording link when it's made available. Your phone lines will be muted until the Q&A session at the end of the presentation. If you need clarification about the material that's being presented during the session, you can type your question into the chat window and Olga will answer those questions, unless a question would be better answered during the Q&A discussion at the end of the presentation. When you exit this webinar, a brief survey will be displayed in your web browser. Thank you for taking a minute to complete this survey. Genesys uses this feedback to improve our tech tutorials. And now I'm going to turn the presentation over to Andy.
Thank you, Anne. Hi there, everybody. My name is Andy Votor, and I'm one of the product experts for GIR within the Voice Self-Service group of Genesys Customer Care. So today we'll be doing Genesys Interaction Recording installation with screen recording, and I'll start the presentation. It's in a bit of a different format from normal Genesys TOIs. We'll be playing some videos that I've done with the system getting up and running and installing all of the prerequisite components. And then we will be commenting on those so you can see the methodology of how the actual system is supposed to be installed. Just one moment. So the tech tutorial is being recorded. It'll be available on the customer care portal in a week, and you'll receive an email with a link to the recording and slides. So you can ask questions during the Q&A period. The Q&A questions will also be published when the recording and slides are posted. We would kindly ask that any specific troubleshooting questions you may be experiencing in any of your own GIR deployments be saved for the end of the TOIs. Depending on the complexity of the issue, it could be something easy, or it could require a customer care case be opened for further review. We are absolutely happy to help troubleshoot, but the presentation needs to be completed so we can track questions appropriately. But regular questions during the TOI are welcome for Olga to answer. So the tech tutorial covers several topics, the instructions for installation and configuration of GIR components, including RPS, the recording processor script, RCS, the recording crypto server, RMS, the recording muxer script, the recording plugin, and screen recording client. And then the supplementary components, SIP Server, GVP, Icon, WebDAV, Web Services, are all found in the GIR Solutions Guide on the Genesys documentation site. Any of you familiar with the current GIR documentation, the deployment guide is no longer found. It's all within the Solutions Guide. All of the instructions for installing web services are found on the Genesys documentation site, and the instructions for installing Speechminer are also found there. They each have their own documentation sections. So the versions of the software we're going to be using to do the installation are as follows. We have SIP Server 8.1.101.16. The SIP Server in older versions won't work due to lack of some specific MSML options. Specifically, MSML record metadata support was not available in previous versions of SIP Server. The RM 8.5.050.34 was used. MCP, we're using 8.5.100.5.9. Some versions of 8.5.0 MCP had some issues with passing metadata properly to a recording processor script. But since 8.5 and above GVP are no longer under shipping control. We suggest using the versions available on the downloads website that are generally available. For recording crypto server, we're using 8.5.005.82. Recording processor script, we're using 8.5.000.31. Recording muxer script, we're using 8.5.211. Recording plugin for jacks, we're using 8.5.004.78. And then screen recording client 8.5.204.04. Speech and text analytics, also known as Speechminer, we're using version 8.5.300.03. And then web services. Initially we were using 8.5.200.50, but we reverted to 8.5.200.42, and I can explain that tomorrow when it becomes more relevant. So most of these components work on Windows and Linux. I've chosen to do the majority of the installations on Linux since that's what I'm most familiar with. The exceptions to this are the screen recording client is Windows 7 64-bit only at the moment. Speechminer itself is Windows Server only, either Windows Server 2008 or 2012, and web services is currently Linux only. So the content of the videos is meant for review to demonstrate the step-by-step procedures for deploying the software. It assumes framework, GVP, SIP Server, JAX, and Icon have already been deployed and tested. It starts with web services, Cassandra specifically, Jetty, web services itself, meaning HTCC, configuration options, recording settings, then moves on to WebDAV, installation and configuration, RPS install in GA, Speechminer database and software installation, then configuration and including deploying a new user to log into Speechminer, RCS deployment, and RCS plugin installation. The version of, sorry, there was a question. The version of Windows for screen recording client was Windows 7 64-bit for the screen recording client for agents. The actual version number was 8.5.204.04. So for the agenda, we'll be doing the software in this order. Web services, Cassandra, Jetty. Web services, you may hear me refer to that as HTCC. That's one of the names that was used for it before it was known as web services. We'll be doing WebDAV, also known as Apache HTTPD, Speechminer, recording processor script, recording crypto server, the IVR profile, encryption, and the recording muxer script as well. So for Cassandra, the cluster size that we're going to be using for this deployment is just one, so we're only going to be using one node. The replication factor is 1, so the data is only stored in that one location. For the consistency levels, the consistency level of 1, we are reading from one node every time and writing to one node every time. So one possible deployment option is for high availability, and usually that comprises a cluster size of 3 nodes with a replication factor of 3. So what this means is that your reads are known as eventually consistent. Means that for this particular read-write level, all nodes will see the same data. Eventually consistent means that you might get old data from some nodes and new data for others until the data has been successfully replicated and synchronized across all devices. So the idea is that this way you can increase read-write speeds and improve tolerance against potentially dead nodes, which is the purpose of high availability. You can survive the loss of 2 nodes. How many nodes can go down without the application noticing? This is a lower bound. In larger than 3 clusters, you could lose more nodes. If they happen to be handling different parts of the key space, then you wouldn't notice. But with the consistency level of 1, you're really reading from one node every time. The more nodes you read from, the more network traffic ensues and the bigger latencies involved. Cassandra read operations won't return until at least this many nodes have responded with the same data value. So we're limiting the amount of computation required. So each node in this configuration would hold 100% of the data. So the bigger your cluster, the more the data gets distributed across your nodes. If you're using the random partitioner, this is how much data each of your nodes has to handle. This is also how much of your key space becomes inaccessible for each node that you lose beyond the safe limit. But with our current safe limit, we're fine to lose 2 nodes. So I will start the videos and we can see how Cassandra is going to be installed. So you'll notice a little bit of screen tearing at the beginning. That's just part of the screen recording software that I used. It was not GIR. So first what I'm doing here is I am extracting the Apache Cassandra and moving the file, the folder within the file system to point it to my installation directory, opt_cassandra. I'm then changing into that directory and going into the configuration folder and backing up my existing cassandra.yaml. The cassandra.yaml file is used for all of the main Cassandra settings. So here I'm copying from my HTCC packages. I'm going to replace the initial cassandra.yaml that was there with the one from the installation folder of HTCC. And here I am editing the cassandra.yaml. So we first changed the cluster name. This has to be unique across all nodes. So I'm changing the name from test cluster to something that's unique for my environment. Because I'm only using one node in my environment, I'm not setting an initial token. The hinted handoff throttle delay in milliseconds is an option that I'm disabling for now. It's known to cause issues. I've actually left one of these problematic issues in for later correction, so you can see how it's done. The seeds, these are all of our nodes. So I'm changing it from the default value of the loopback address. I'm changing this to the actual IP address of the host server. The listen address, I'm changing this from localhost. I'm sorry, apparently there's some problem with the video playback. Is anybody else able to confirm if they're able to see the video being played back? Oh, great. But you do see the fact that it's playing back. Great, thank you. So the listen address, we have the IP address of the server. So I'm changing this to the actual address. So it's 135.17.130.52. You'll see that one a lot. That's my main Cassandra recording processor script, recording crypto server that I'm doing the installation on. So the RPC address is the same thing. I'm making it the same interface. Data file directories. So this is where Cassandra will actually be storing all of the files that it commits to disk whenever it writes to the actual file system. This is where it will be writing to. So this file, this folder doesn't exist yet, so I'm going to specify it and then I will create it. So the commit log, same thing. I'm going to create this folder, opt_cassandra commit log. So you're noticing I'm putting it in the same directory as my Cassandra installation. It's in opt_cassandra. And then I do the same thing for the saved caches directories, which I'm going to change from varlib Cassandra to opt_cassandra saved caches. And I'm finished editing. I save my file. I change directories to Cassandra, and I make all of those folders that we had referenced previously, the data, saved caches, and commit log. So we go into the configuration file, and we edit the logging levels in the log4j server properties file. Here I'm just changing the log4j appender to point to opt_cassandra system.log. It is where I want my Cassandra logs to go. And I save the file. And now we'll try and actually start Cassandra. And so we execute the Cassandra, and I have an error. So here's where I try and determine the source of the error. It's experiencing an exception, cannot create property RPC timeout in milliseconds. So I have to go into my Cassandra YAML and correct that value. So there's the value, and I just comment it out. So we restart Cassandra, and this time it's successful. You can see startup complete, now serving reads. So Cassandra is up and running. And again, I apologize about the screen tearing. That'll go away. It's here we're doing a search. We did a PSEF grep for Cassandra. We want to see and confirm that Cassandra is running on the Linux box, and it is. So we change directory to our HTCC installation directory. These are where our key space schema and column family schemas are for deploying into Cassandra. So these are what allows HTCC to populate the database of Cassandra. So we execute the Cassandra -CLI from the Cassandra installation directory, and we specify the host. which is the same server, and we point it to the file of keyspace schema local.txt. This file would vary depending on which installation you're doing. If you were doing a 3-node ring, you would use the prod, and if you were doing a multi-data center deployment, you would use the prod HA. So you see it connects to Cassandra, and we have the confirmation returned from Cassandra that the data was populated properly. So here I do the same thing with the column family schema, and this one has much more information in it. So it connects and populates and now all of our data from HTCC is in the Cassandra database. So here we've changed to GA, Genesys Administrator, and we are deploying our application template. The schemas are part of the Genesys package. They're not included with Cassandra. So we deploy our template. This is part of the HTCC installation guide. I'm just creating a generic client, and I'm naming it www.ews. I'm hitting apply. So next I'm uploading a template, and this template is provided as part of HTCC. So we provide the APD file and upload it into GA. Then we import the metadata. So before we had created our own Genesys generic client node. Now we are creating the Genesys generic server from the template that we just uploaded. So Workspace Web Edition works as part of 2 nodes. The client connects to the cluster and gets the information from the cluster object. So we will be now deploying our server and connecting it to the client. So I'm just going through the motions of adding the application object into my environment tenant and then choosing my host server to install it on. Choosing the listening port. And the working directory and command line are not used. We just put dots or periods. And we add a connection to ConfServe. And a SIP server. So now I'm creating my client object. and connecting it to the cluster object that I've just created. So this will be Jetty that we're doing now. Jetty is the web server that web services will run on. So web services is a web application that runs on top of Jetty, which connects to the Cassandra database and retrieves this information from there. So we've finished our prerequisite of Cassandra. Now we're working on the actual web server itself. So I've unpackaged the Jetty from the installation download that I received from the internet, and I'm now renaming it and moving it to the installation directory, and we're changing to that directory to start the configuration. So here we are copying the files provided from HTCC for Jetty. We're copying the Jetty XML into the etc folder inside of our new Jetty installation directory. We're copying cloudweb.xml into our web apps directory. And we're copying logback.xml into our resources folder. So here we are copying the actual WAR file. If you're familiar with Tomcat or Jetty, the Cloud Web WAR is the actual web application that Jetty runs to provide web services to run the HTCC application. So here we are creating our configuration folder, genconfig. This will house all of the all of the configuration files for HTCC to run from Jetty. So we're going to copy all of these files from the HTCC installation directory, from the conf folder, and I'm just copying all of the YAML sample files into my Jetty installation directory with the genconfig. So now I have all of those configuration files, and I can change them from being samples to their proper YAML names. So we've first started with Cassandra cluster YAML, and we've moved on to the Hystrix properties. Then we do Elasticsearch and the on-premise settings. This is for connecting it to configuration server. Then server settings. Those are the actual HTCC configuration files. And statistics.yaml. This is for stat server integration. So here we are editing the Cassandra cluster YAML. This is how HTCC talks to Cassandra. Red Hat Linux is the version that's supported by Genesys. So I'm just adding my nodes. You'll notice this nodes is the same as the seeds that we provided earlier in configuring our Cassandra. The replication factor, I'm keeping it at 1. And the write consistency level and read consistency level, I'm keeping at 1 as well. Cassandra version, I'm keeping at 1.2. And you can also have SSL for HTCC to talk to Cassandra over a secure channel. So here we are editing the on-premise settings. This is how HTCC will talk to configuration server. And I actually made a mistake there. That's not my configuration server IP address. That one is. So we change the port, and you can match country codes, and you can also have TLS enabled for secure communication from configuration server to HTCC as well. Server settings. This file is the largest file for HTCC and contains the most options. The latest version, 8.5, which one was it? It was 200.50, contains all of the options commented out by default. All of the versions before this did not have all of these options available for changing. So here we're specifying our API URL for HTCC. The web services portion, we will be sending API calls, HTTP API calls to HTCC just through our console and also from Speechminer and Recording Crypto server. So the default format is http:// the IP address and running on port 80. The API v2 and the internal API are uniform resource indicators are hard-coded and should not be altered if possible. The undocumented external API URL is used for Recording Crypto server access specifically. So here we have just some general options. So all of these options are available in the HTCC deployment guide if you need anything specific. So here we're specifying the ops username and password. So this is the master username and password, the root username and password for HTCC. So this account ops would have all privileges. So here we're changing the application name to match our client application object that we've configured in the Genesys administrator. So sync node is extremely important for at least one node. One node has to be the sync node for HTCC. If you're deploying multiple HTCC nodes, then only one has to be the sync. So Elasticsearch, we will configure Elasticsearch in another video. Elasticsearch indexing is used by HTCC to search through call recordings. So the CR cluster name has to be unique. Every node in the cluster has to have the same cluster name. They have to be a part of the same cluster. The region has to be the same for all of the same nodes in that area that you wish to have access to the same storage. Crypto security key is for encrypting our call recordings. So in order to properly initialize our call recordings with security, they have to be encrypted in the database, and this will be the key that's used to encrypt them. It can be anything you choose. So this is for call detail recording. The VSSO7 is my host name for this server. The node path is the region, you'll note, with the voice monitor node ID or the node ID. They should be the same value. So our Elasticsearch settings, I'm just removing the comments and changing the client node to be false. Since this is our initial node, we want this to be the server for Elasticsearch. So we're setting the client node to be false to make it the server. So I'm disabling the denial of service filter. The HTCC application can also be used in a cloud environment for hosted support. So that option is for denial of service attack mitigation. This is a lab, so I don't need it. And here we are editing the elasticsearch.yml. You'll notice this file name is not the same. It does not have an A in the end file extension. So I'm adding my host. And then I have to create these paths. So this is where Elasticsearch will store all of its data, just like a database. I have to create this folder because it doesn't currently exist yet. So I've made it the templates folder, and then I'm going to make a data folder under the templates. So I've now finished editing all of the YAML files and my elasticsearch.yml file. I'm now making my templates and my data folders. So Elasticsearch templates, I'm copying the JSON files, which is the format of the templates, into that templates folder that I just created. The JSON templates were in a part of the HTCC installation package. So these options here, the sysctl commands, are being copied and pasted from the solutions guide, or sorry, the HTCC installation guide. These are for optimizing the Linux host for memory usage and for network support for HTCC optimization. So the elasticsearch.yml, we're moving that into our resources folder. That's where it stays. It doesn't belong in the genconfig folder. So here I am just creating a script to start HTCC. The actual start command is found in the HTCC installation guide. I chose to make a script to make it easier for myself to stop and start HTCC. So we have some Java options you'll see at the beginning. We have to change the port. The default is, of course, 8080. In the Jetty logs directory, where do we wish our logs for HTCC to be output to? I'm putting them in opt Jetty logs. The config path, this is the file to our opt genconfig, opt Jetty genconfig, where all of our configuration files are found for HTCC. What is my installation folder for Jetty? It's the djetty home, that's opt Jetty. You'll notice the temp directory is also already temp, and then the final option, I'm pointing the jar file to the start.jar found inside of the opt Jetty. So I make my script executable. I make a change in it to make it run as a daemon. The no hangup is for it to continue once I exit my shell. So we can see inside of the no-hop file that the application has started. And we're going to monitor the cloud log, which is the default Jetty log name. And you'll see this was not a successful startup. I have an error that I will be correcting in my server settings YAML. This was done intentionally to show you what the errors look like and how they can be troubleshot. So the ps-ef grep start jar, that's the command to find the process ID of Jetty or HTCC. I then kill the process ID and remove the logs and the no-hop file and go back to my server settings and make corrections to the file. So in that case, it was my WebDAV max connection and WebDAV max total connection being empty that was the problem. So we're back into the logs, and the log doesn't always immediately generate. So you'll see this looks a little different. We can see the normalized node path, so the VSS07. And inside of that large chunk of text, the server settings, you can see all of the current values that HTCC was able to pick up from the server settings YAML. So we have our Cassandra initialization. We can see the Cassandra cluster has been changed to active. So HTCC was successfully able to talk to Cassandra and pull the information from the database. So those are some of the different things that you can expect to see in the HTCC logs. Many things to do with the Elasticsearch. And we've got a successful pull of the information from the configuration server as well. If any of this was unsuccessful, you would see a normal Java crash stack that would need to be reviewed. So here I am testing with curl. So curl is a Linux command to interact with the web API. So my command is, you'll notice -v, that's for verbose. It's so I can get more information. I can see all of the actual HTTP headers. And the U is for ops, so I'm authenticating to the HTCC ops account. And I'm going to the diagnostics version page. So you can see if the connection is successful, I issue the GET with my authorization header. It shows the host, and then the server returns 200 OK with a status code of 0 and shows the version number. So that was a successful start of HTCC. So in this video, we're going to look at the recording settings. So I'm editing a file called recording settings. And again, all of these configuration parameters are in the GIR solutions guide. So previously when we were doing the HTCC, that was all in the HTCC deployment guide. Now we've moved into GIR, and this is the GIR solutions guide. So I'm setting my WebDAV username and password. I haven't created the WebDAV settings yet. We'll do that in a later video. So you'll notice this is in JSON format. my editor is showing where I can terminate my JSON formatting properly. So that's the final file. And then we do a command found in the GIR Solutions Guide to send it to the API. The solution guide is still under shipping control restrictions as far as I'm aware. I'm unsure of when product management intends on releasing it to the general public. So you can see the command was successful. The purpose of this command was to pull the contact center ID. So I've queried the API v2 ops contact centers, and it's given me a 200 OK and returned the contact center ID. So this contact center ID is created on startup of HTCC and is populated on its own. So this command I'm doing now is for sending the contents of the recording settings file that we edited just a moment ago. And I'm going to do an HTTP put with the contents of that file to the URI shown here, which is going to the contact center ID /settings/recordings. And I'm modifying the headers so it's being sent in JSON format. If this was not done, then the request would not work. So you can see here, we connect to HTCC and we return a 200 OK and a status code 0. So the HTCC recording storage settings are now saved, and HTCC now knows for voice recordings what the username and password of the WebDAV storage location is and what the URI is to fetch it. And the status code 0 and the 200 OK confirm it was successful. So in this video, we're going to install HTTPD. I'm just going to skip through this one a little bit. WebDAV is provided as part of the HTTPD package, and you can see I already have it installed. So I'm going to make a directory for var WebDAV. This is where I'm going to keep some of my recordings. And then I edit the etc httpd conf httpd.conf. So this file is the httpd configuration file. So we just skip to the very bottom using all of the default options. And configure it as per the GIR Solutions Guide. So I've decided to customize my directory a little bit. I'm sending it to var WebDAV recordings instead of a mounted file system. So we're just editing the options. Again, this is all as per the GIR Solutions Guide. So you'll notice here I'm setting the WebDAV username and password. So the auth type of basic tells it to look for the authorization in the file that I'm specifying in the auth user file. So I've set the username as WebDAV, and I'm pointing it to that file to find the encrypted password. I'll create that file in a moment with the encrypted password. So I've made some mistakes in here, and you can see I will start HTTPD and show you how to correct them. So here I am just checking to make sure HTTPD is set to start automatically when the Linux system boots. So I'm setting the check config level of HTTPD to be on. So this command will set HTTPD or WebDAV to start automatically when it's booted. We're changing directory to our WebDAV and making our recordings folder where we'll store our recording MP3 files and MP4 files for screen recording. It is possible to have MP3s and MP4s on different storage locations. So here I am generating my encrypted WebDAV password. So the syntax of this, again, is in the GIR Solutions Guide. So I'm creating it for the WebDAV user, and the password I've been typing is just WebDAV. So I'm now restarting HTTPD, and it shows I have an error. There's a syntax error on the line 1018. I'm missing a closing bracket. So I have to edit my file and make that correction. So I think I fixed it the first time. It's a different problem. I'm missing another bracket. Restart HTTPD, and we run a test with curl. So first I'm going to create a new test file. And confirm that the upload works. So I create it with just this as a test inside, and I run my curl command with WebDAV as the username and password. And I send it to recordings as helloworld.txt. I receive a permissions error, so I don't have permissions to do this. So we go to our var WebDAV, and if you see, the permissions on it are root and root. Our WebDAV application, our HTTPD, runs as the Apache user. So we have to change permissions, file system permissions, on the server to make the owner Apache. So we make that change, and the upload is now successful once we have permissions to write to that directory. So in this, I'm checking through my web browser that the recording's WebDAV is also working. It's going to prompt for a username and password. And I have my text file inside with the text I created earlier. Now the WebDAV has been complete, we can work on a recording processor script. So I'm just changing directory into the recording processor script downloaded install folder and running the installer. So I've installed it to the opt_rps directory. So by default, there are several third-party libraries that come with RPS that need to be installed first. httplib is one. Python dateutil is another. We also have setup tools and web.py. So I'm just extracting these prerequisite programs, and we will do the install of each of them. So again, all of this is in the GIR Solutions Guide now for the installation of RPS. It includes instructions for both Windows and for Linux. So that one returned an error, and it was due to the fact that I had already had a conflicting version of setup tools installed. So I already knew this, so I just ignored it. The recommended version of Python is 2.7. And Python is a prerequisite for RPS. The recording processor script is a Python script. So now we've completed our third-party prerequisites for recording processor script. So we go into our RP directory and we edit the rpconfig.cfg file. This is the file that holds all of recording processor script's configuration. So the descriptions for all of these, there's a small description inside of the file. We have our basic authentication username and password that I'm editing here. This is to authenticate to RPS as a server. We'll look more at these values later with the IVR profile. So the default values for almost all of these are acceptable. The default port that recording processor script runs on is 8889. The address, if you set it to all zeros, it will listen on all interfaces, all network adapters. The base URI, we change this to be the URI for web services. This is if, for some reason, if there's an error and recording processor script receives a file but doesn't receive the metadata telling it where to send it to HTCC, this is where it will send it as a backup. Again, we have the ops username and password. This is for recording processor script to talk to HTCC successfully. You can configure certificate validation if you have HTTPS enabled. We change the config server hostname so recording processor script can pull information from the server, the Genesys configuration server. And the icon DB servers. Here, you'll notice the name is SIP_switch. Within this configuration file, the value on the left, the SIP_switch, needs to be the same as your primary switch name within Genesys. So the DB server host. This is the icon DB server, meaning Genesys DB server application, host and port information. So I can go into my GA and check these values. So I confirm that it's running on 4040. Then I change my username and password for my MS SQL account for my GIR database access. So the DBMS information is the IP address and port of the actual MS SQL instance running on possibly a different server. In my circumstance, it's running on the same server. So you would have one reference in the host and port up above pointing to the DB server, and the DBMS information pointing to the actual MS SQL information. The DB engine, you'll note, is currently MS SQL. GIR also supports Postgres SQL, and as of the latest several releases, supports Oracle. So here I am editing the log file path where I want to send my debug level logs for troubleshooting recording processor when it has some issues to start. So I'm just changing all of these levels from info to debug. manual command to start recording processor script is found in the solutions guide. So I'm just testing it within the console without setting it up in GA, but I will set up the RPS application object in GA in another video. So you can see it starts successfully. You can see the started with command line option. The info contact center near the top is very important as it indicates that the contact center ID from HTCC has been successfully discovered and pulled. The order of starting is important with recording processor script. If HTCC has been unavailable for too long of a period, then there are times when the recording processor may lose the contact center ID and not be able to post to HTCC. If that happens, then you just need to restart recording processor script. So we see the opening connection to configuration server, and we can pull the switch object and the person objects. So it's pulling all of the agents in this test environment, and then the agent IDs of all of the test agents. We also see that the processing thread is started and that it opens on the 0000 IP address, which is all IP addresses, and then listens on the 8889 port. So I'm going into my GA, and I will be configuring an application object for use with recording processor script, so I don't have to start and stop it by the command line every time. So I've made it a third-party server, which is a normal application template type within Genesys. I point it to my host. There is a test string with curl available to test if RPS is working properly. We can go over that tomorrow. I don't believe I got this right the first time when I was configuring it, so I'm just going to skip ahead briefly. So I start it, and there is an error, and I check through the local control agent logs, LCA, to determine what the exact error is for the startup. And again, configuring this application object within GA to control recording processor script is also in the GIR solutions guide, the same as the one for creating a similar application object to do recording Muxer script. So that time it worked, and my Genesys administrator is now able to start and stop my instance of recording processor script. So we've got about 10 minutes left, and I think that that's a good point to break for today. There's still a lot more information to cover tomorrow, so we can do some questions now and cover any of the things you've seen and maybe didn't understand or would like some clarification on, and see if there's anything, any specific questions you have. So we have some questions coming in. Yes, Framework Server can be on Windows.
Andy, I'm going to unmute some lines if you're willing to take questions from the phone.
Yep, sure.
Okay, I'm going, Martin, do you have a question for Andy?
Hi, Martin.
It's not me.
Oh, okay. I just saw that the hand.
Well, you got it right. The version for the screen recording client. But hi.
Oh, okay.
Very good presentation.
Oh, thanks.
Okay, Mohammed, okay, Mohammed, I'm going to unmute your phone line if you have a question. Okay, I'm going to, Mohammed, if you have a question, you can submit that through the chat window. We're getting a lot of feedback on your phone line, so if you're able to submit your question that way, that would be great. Let me see. That looks like those are all the questions that have come in on the phone line. Andy, are there any other questions that?
Okay. Yeah, I will review Ying's question that he had about the region within web service. So let me just see here. So I'm going to share my screen from my active GIR deployment with my recording processor config, just so you can see Ying. Within the metadata subsection, there's a region value assigned to metadata by this recording processor instance. So we have region equals region 1. So this would be the recording processor side, and then, yes, Olga is correct with the CR region side being within web services. So if we go into opt-jetty gen config, within CR region is currently set to US. So languages is an excellent question. I guess it depends on what you mean by support of the language. The recording solution definition file has a limitation that it can only be deployed onto an English language configuration server. However, if you mean encoding for icon or the icon database or metadata to support alternative character sets, then icon is able to support those, and recording processor script is able to modify the encoding it uses to support these characters. So if you mean as far as the metadata, then yes, other languages are supported. For Tausif's question about a separate MCP for GIR, it's recommended strongly to have a separate MCP for GIR. However, if it's a small environment, then it's not necessary. Just the one MCP will suffice if there's a low call volume. However, if it's a high call volume, then the recording can be intensive, CPU intensive for MCP, and it would require a separate MCP instance. For Martin's question about Cassandra running on RHEL, I will have to look into that question. I know we support some other Genesys applications such as ORS with Cassandra. I'd have to validate if they support the Cassandra running on a different operating system, or if it's only for Linux. I know HTCC and Jetty specifically need to be on RHEL. So Letitia, about the recording files, MP3s being stored on Linux server, that's just in my environment. I've configured my WebDAV to be on the Linux server. That's not exactly true. WebDAV is able to run on either Linux or Windows. The documentation that we have, however, is a little more clear for Linux, and I just happen to have a Linux server that was powerful enough to run all of these applications, so I chose to do my WebDAV deployment on Linux. But WebDAV will work with Windows. The configuration files on it, though, aren't quite as clear. For Alexandra Guryanov, the SIP switch option in RPS config must be equal to primary switch name. No, there is no icon 1 switch that I have in my system, so only the left-hand value of the parameter I was showing you needs to match. So the switch name needs to be SIP_switch. The icon 1 you're referencing, that is actually the below section of RP config that is for mapping the switch to the icon database that would be talking to that SIP server associated with that switch. For Ying, the WWEWS cluster via Genesys Administrator will not ever show as started currently. It's intended to be just there as a representation of the logical application object. It's not for starting and stopping HTCC. It's possible that somebody has figured out a method yet, but they haven't shared it with me. So I think for the rest of these questions that I haven't yet answered, we will take them back and do some research as to what needs to be researched to properly answer them, and we will have some answers tomorrow that we can cover in tomorrow's Q&A. I don't believe it requires a separate icon. I will review the documentation and check on that too. The one caveat with icon is that it requires the database purging to be enabled on icon, as it is a fairly CPU-intensive process on icon as well. There's also some SQL indexes that need to be run on icon in order to lower the CPU usage being caused by recording processor script, as there are many queries that go through from recording processor script to icon. So I believe for if you require long-term storage within the icon database, then you would definitely need a separate icon, as it will require a different amount of storage. I'm glad you enjoyed it, Roman. I hope it was useful. So we'll cover some more topics for tomorrow.
So Andy, you're going to take these other questions and we'll address them tomorrow. Is this a good stopping point for today's?
Yes.
Okay. So thank you everyone for attending. The part 2 of this tech tutorial will be tomorrow at the same time slot that we had it today. Again, this recording will be sent out in approximately a week, along with any questions that were submitted that need to be researched. Thank you very much for attending.